the paradigm is insecure and it's inconvenient. Every time you have to register, log in. Now people use login with Facebook, login with Google, login with etc. But it's still you're giving away um, your authority over your own identity to somebody else, and they can not only reveal your password, which you may use on other sites, and then that would be a bigger disaster, but also they get to hold um, all your information, everything about you gets accumulated in these services, and it's not very nice to the user, right? It has many privacy implications, security implications. So what we're going to use, this is a follow-up to the upload protocol where we did real-time encryption that was giving us um, 3 times the bitrate, the bandwidth, to upload our stuff very quickly, and multi-threaded uploading with web workers and web sockets. So the new paradigm I want to show now is how do you um, not log in, and how do you retain authority over your identity. And it's using a concept known as zero knowledge proof, and there are many implementations, many sub concepts with it, and many different ways of doing it. Some more zero proof, zero knowledge than others, and some more secure than others. And so the way we're doing it right now is the user never has to log into the application. The application um, does not even have to retain much data about the user except the data that it needs for its own administration. So whereas Facebook retains all of our data, it doesn't need to know that I message my wife something about our daughter. By the way, they monetize that, and they index that and play advertisements based on your private messages, which is extremely creepy. As they say, the fish rots from the top down, from the head down. Everybody at and Facebook has proven that they're extremely creepy, and people still use them because they have no choice. But we need to change that, right? And so um, the technology has existed for at least 10 years to do this. This is nothing new. This is just on a whim I decided, I'm bored, using passwords and cookies and web tokens and all of that, and I wanted to do something far more secure and far more private and empowering to the user. So the way it works is simply using strong encryption. In this case, it's called RSA OAEP with the SHA-256. We can go all the way, 512, SHA-512, or we can use different encryption algorithm. But this is about generating a private public key pair, and presenting the key pair to the site, where if the site has seen that key pair, it can remember some minimal information about it, like how many, say in this case, how many uploads you're allowed to upload at the same time, how many files you're allowed to upload at the same time, based on your, say, payment history or something for this service. It may remember some parameters, control parameters, but it doesn't remember what files you've uploaded. Everything is encrypted with your all the content that you put on the site and to the application is encrypted with your public key, and they cannot encrypt it. The provider cannot encrypt it, the app cannot decrypt it, I mean, without having access to your private key. And there is no way to have access to your private key in this instance because it's created in a non-serializable fashion, non-shareable fashion. It's opaque to the browser. It sits outside the browser, and basically the browser exposes only its properties, not its data. Its data remains opaque outside of the browser. So no process inside the browser has access to that, to your key, to your private key. So your public key is what you give away, and it identifies you. And your private, and it's used by the services to encrypt all your data. And once it's encrypted, which is part of the contract, I mean, if they leave it in plain sight, then you dump the service, but and there's always the legal framework around it too. So if they represent that they don't encrypt it, you don't have to use them, or you don't have to give them any data, such as, for example, it's not an upload service. It could be a weather service, that you're using, and it just remembers your settings, but in case of Facebook, Facebook could use this and encrypt all your data in a way that they cannot see it. They cannot see your data. Only you can see your data. And so what we're going to demo here is a very secure way to not only have your private key not accessible anywhere from within the browser. It's accessible and outside of the browser process space. So basically, no other page, no other tab can somehow gain access to it. They can only at most, if they penetrate into the IndexedDB instance for the given domain, they from another domain they can, or if the domain itself injects some JavaScripts to do that, it's the key is created in by the user in non-serializable fashion, and so it's data the key signature, the key content itself is lies outside the browser. And so sure, if you have a malware with root access on a Linux system, it can dump the memory and look into it. And but in this case, your whole machine is infected. So anyways, without much more explanation, let's see how this works. I'm uploading a file. I could upload 2 or 10 like we did in the previous demo. And this is over very low speed network. So anyways, it's let's see what happened here. So keys were not fine. Generating keys with browser opaque values in non-serialized form. Loaded the key pair. And so if we look at the keys, so the public key is extractable, meaning it's serializable. The private key is not, and there is no data. The data for the key does not exist in IndexedDB itself. I mean, it is within IndexedDB, but it's outside of the browser process, and that's the power of it. So there's no way for anyone from outside to access it. It's not even. It has to be something that happens within the process, and then it cannot be serialized out to another process. So it cannot be accessed from one tab, from another tab. It's extremely secure in that way. So on this side, what else we see happening? So we're extracting, serializing the public key, sending it to the server. And this is something to do with the console log. After the keys is after the process exits, you don't have access to it. So then we send it to the server. The server used the key, imported it, and used it to encrypt a random message and send it to us as a challenge to figure, if we have the private key, then we can decrypt that message, and only us can decrypt message. So then we loaded the key pair again, and we're using the private key pair without exposing it again. It's not extractable. We're just using it. That's something in web crypto allows. We're able to use it without serializing it and without exposing its value outside of the process. It's if we try to export it, it will throw an error because it was created with the extractable flag set to false. So in this case, the random statement was high there. I mean, we can get creative with word sentence synthesis. Very fast random sentence synthesis, or random UUID or whatever. And then on the server side, I solved the authorization challenge, authentication challenge. On the server side, we see that server got connected, received serialized public key from client, imported serialized public key, sending encrypted authentication to client. Client proved its claim to the key, received start signal, streaming. Yeah, and make sure, if there are no other, this is calculated storage available, so it doesn't store more, and all done. That's it. So next time we go to the site, if the site has stored anything about us, such as which files we uploaded, it will remember again, and because it identifies us with the public key after we prove our ownership of it, through this challenge process. So that's how it works.